Welcome to Miss Lam's Math World. Today we are going to discuss this question, 1995. So in this question, we have three parts, part A, part B, and part C. And then for part A, it is a kind of standard type question. Alright, that means it is not difficult if you understand how to use the compound angle formula, then you just need to expand the right hand side and you will get the result of the left hand side. Okay, easy. So our objective is to discuss part B1, B2, and part C. So part B. First, ABC is a triangle. So this piece of information is very important, okay? This piece of information. ABC is a triangle. And using A, that means this one. Show that cosine square A minus cosine square B plus sine square C equals to 2 cosine A sine B sine C. So let's recall what we have learned before. Do you remember this question? A really crazy one. So you see in a triangle ABC, so we can use the information, right? I'm saying use the information. A plus B plus C equals to pi. So use it to simplify the ABC, right? So if you still remember, we've done something like this before, and it was so scary. Huh? So we will use this often, and also cyclic. I don't know. So this time is a little bit different, but we may also have a look on it. And this one, cosine pi over 2 minus theta equals to sine theta, will actually use often. And also we have learned about the phase quadrant before. So this is a revision, right? So we've learned this 1, 2, 3. So this time the cycle is not really that useful because the C is different. Let's revision. So to summarize, so that means first we have to substitute the result of A. Secondly, we know that A plus B plus C equals to pi. And then we may probably need to use the sine or cosine. For instance, I just write down cosine, okay? Pi minus theta, maybe, okay, pi over 2, sorry, should be sine theta, or in a reverse way. All right, and then also we may need to use cosine quadrant 4, right? Cosine minus theta equals to cosine theta. And also for quadrant 4, sine negative theta equals to minus sine theta. So we may need to use that. So when should we use which one? So it depends on how to make the left hand side to be the right hand side. Okay. So let's start the calculation. First, of course, it is much easier to start with the left hand side because you can see this one is exactly the same as part A, and we can substitute at once, right? So substitute. You will get this one. And then, so we can start to think how to make this one disappear. Because we have addition. Oh, that means we can't just do it in this way, right? But first, maybe we can consider A plus B here. Because A plus B plus C equals to pi. And then we can simplify a bit first. So we can get pi minus C, this one. Why we need to do so? Because we have a plus sign, that means we can use the product to sum formula, right? So this one, sum to product formula, right? Okay, so this one, sine pi minus C, it is in quadrant 2. So for quadrant 2, so it is still positive for sine C. and then take common factor. And you will get this one. Alright, so it's the time to use the sum to product formula. So this is a sine plus sine, so it means sine cosine, right? So let's substitute. So 2 times sine b minus a plus c over 2 sine cosine, right? Sine cosine b minus a minus c divided by 2. So right now at this step, we need to compare these objects inside. Sine c is already done. This one already done. And then the 2 is already done, right? That means we have to handle the number inside. That means one of them will become cosine A. The other one will be equal to sine B. It may not be just having the sine goes to sine, cosine paired with cosine. It may not be like this, okay? So how can we know whether it is sine or cosine? So we should check the sign by using the substitution. And we try to make 3 letters to be 1. That means we choose the letter, the variable, which is having the sign opposite to the other 2. Okay. So that means this time we are using number 2 again. So how to use the number 2 again? If you're not sure, then you can write the step again. This time I only want to get B plus C to be the subject for the substitution. So B plus C equals to pi minus A. Substitute. And then do that similarly for cosine B minus A minus C. So for this one, A and C are having the same sign, then A plus B plus C equals to pi. Maybe I move to here so that you can see clearly. So I want to have minus A minus C, okay? So minus A minus C, so it's equals to B minus pi. As a result, we will get pi minus 2a over 2 and cosine 2b plus b minus pi divided by 2. Okay, so we need to simplify this one. So if you want to simplify, because we have the over 2 here, so we can't just simplify by using the identity right now. We cannot. So to do so, we have to separate. That means split the fraction in this way. Cosine b minus pi over 2. Okay. Is that clear? This one. b minus pi over 2. Okay, 2b over 2 is b. And then this one minus pi over 2. Okay, so as we know that from the question, we only got A, B, and C, right? This is not clearly nice enough, so we can use this one, cosine pi over 2 minus theta equals to sine theta. So this one, sine pi over 2 minus A will be equals to cosine A. Wow, we are very close to the final answer. That's wonderful. Right, so this one is b minus pi over 2. So this one is pretty troublesome because it should have pi over 2 minus b, something like that. Okay, so we have 2 methods. Okay, method 1, then you change to cosine minus pi over 2 minus b. So we can use this one, quadrant 4, to simplify method 1. Okay, method 2, if you still remember, we can actually add 1 cycle for it. That means we can add 2 pi. After we add 2 pi to it, you will get 3 pi over 2 plus b. So it is quadrant 4, okay? Cosine quadrant 4 is positive. And then we can change that into 2 sine c cosine a sine b. So let's check the answer. Equals to 2 cosine a sine b sine c. Hooray! So we got the answer. And then we got the answer at last. Right? So try to use practice to use the sum to product formula, and also the most important part is to how to handle for the quadrants and angle sum of triangle. You see, we use it again, similar to the one in 1999, and also similar to the one that you dislike the question a lot, right? The last example. So let's move on to the next clip for part B2 and part C.